Hello, we are Project Ecoficiency, and we are competing on the Chevron Track. Let's start off with the importance of the challenge. Global warming is a current existential threat to humanity, but its effects can be limited if society begins transitioning into renewable energy sources. Chevron is looking to lead investment into the renewable energy transition by looking into states where renewable energy investment is high. Using this data set, we can help Chevron pinpoint the best states to look into for renewable energy investment and therefore help accelerate the green energy transition.
Now let's talk about data cleaning. We removed all data that didn't have a total assistance value associated with it, and this removed all information from the District of Columbia and the federal offshore territories. We used 3 predictive models. We used linear regression, gradient boosting, and random forest as models. And now let's move on to results and visualization. As a start, we hope to pinpoint specific regions we can look back into for renewable energy assistance. We did this by graphing the average amount of assistance per state over time for each region within the United States. By looking at this graph, we can see states in the South and West have the highest total amount of assistance per state. This is a promising start, but we need to dig deeper into the data to pinpoint the exact states that may have the highest total amount of assistance.
To better predict the assistance in each state in 2020, we implemented various forms of regression models. Each model took in the amount associated with the 29 MSN codes over the course of 2015 to 2019, along with the CO2 emissions and the number of investments per state. These heat maps show the predicted assistance amounts by state. In the top left are the actual values from 2020. As we can see, the random forest model and gradient boosting model predict the actual data the best, but the random forest model edges out the gradient boosting by a bit. A known weakness of gradient boosting is that models are prone to overfitting, and it's likely what happened given the small and noisy set of data for each set. This is a residual plot of the linear regression model for each state. As we can see, there's a large difference between the actual and predicted values of assistance. This is a residual plot of random forest model for each state. As you can see, there are significantly smaller residuals for this model, which is why the random forest model was our most accurate model, and the one we selected for our final visualization and analysis.
The map on the right displays the states predicted by our random forest model to have the 10 highest values of assistance. As you can see, 7 of these predictions were accurate, defined as also being in the set of the top 10 highest values of assistance observed in 2020. Particularly interesting to note is that our model accurately predicted North Carolina as the state which will have the highest amount of assistance in 2020. In particular, it is important to recognize the significance and relevance of our algorithm. In the case of North Carolina, we firmly believe that it is in Chevron's best interest to seek out collaborators in the alternative energy sector due to the quantity of renewable investments statewide. In the future, Ecoficiency seeks to focus on the following 3 elements of North Carolina's alternative energy economy: renewable energy production, CO2 emissions, and total energy consumption, which have huge significance on future investment outcomes.